Hello everyone, in this video I'm going to talk about how to control automatic air freshener with IoT device called Onion Omega. So to understand this video completely, you need to have a little bit knowledge on IoT devices, basic electronics, Node.js or any computer programming language and Linux operating system. So let's start with the objective. So the objective is to control the automatic air freshener that I bought from Walmart for $7 with a electronic IoT device called Onion Omega. So this automatic air freshener, if you open this, so it comes with a can for $7, which is pretty good deal. So this comes with a switch. So it has 4 settings: off mode, which completely shuts off the device, and it has 36-minute, 18-minute, and 9-minute. That means it sprays for every 36 minutes, uh, as long as it runs out of the battery. So we don't need to go manually and then spray it. But the problem is I don't want to spray for every 36 minutes. For example, during the night time, I don't need to, it doesn't need to spray for every 36 minutes. Or if I'm, maybe during the morning time, I want it to spray like every 30 minutes between 6 a.m. to 10 a.m. And after that, once for every 2 hours. And after 10 p.m., I wanted to spray for maybe once in 3 hours, just to say it. Okay, so but with out of the box settings, as you can see, it's not possible. So somehow we need to hack it. So let's see. If you open it, so we can find a small circuit. So this circuit basically has a timer chip. So what it does is, it calculates, it triggers the motor for every, 36 minutes or 18 minutes, based on the setting you set. So, and it has one DC motor, right? So when, when it fires or when it triggers, the DC motor runs, and DC motor in turn runs the plastic cog wheels inside it. I don't know whether you can see it. So it has plastic cog wheels. So maybe it turns on for every it turns on maybe for 2 seconds or so, and when the cog wheels turns, so it pushes the lever downwards, and which pushes this spray can downwards, and then it sprays. So yeah, that's basically how it works. So what I did is I took out the circuit out of it, and then I soldered 2 wires, positive or negative, or it doesn't matter, just 2 wires to the DC motor, and I disconnected other. So that's all we need to make it work. So take out the circuit that comes with it, and then just solder 2 wires to the 2 terminals. Now let's talk about IoT device. So you might have heard microcontrollers, right? Or Arduino boards. So this Arduino board, it's an open source hardware. So how it runs is, it runs on the ATmeg 328P microcontroller. So you can see it has 5 inputs and 13 outputs. So what it does is you can connect to your computer, and you can download Arduino IDE. It's an Eclipse based development environment. You can write code in C or C++ and then upload it to this. Okay, so what essentially you do is you set the output pins either to high or low. Okay, so when you set high, you can send that high trigger signal to any device. I mean, to the, maybe let's to keep it simple, let's say that you are trying to turn on a coffee machine, so you send that signal to the traffic, you send that high signal to the coffee machine, and then it turns on. So just to demonstrate, so I can turn on LED lights on and off with high and low voltage signals. So but this is Arduino. I mean, it's not original Arduino. See, as I said, it's open source hardware, so that several other companies have started making it. So it's a Arduino variant, so it's called Elego Similarly, so this is Onion Omega, and it's much more advanced than Arduino. As I said, Arduino runs on only, it can run only C or C++ program. But this chip, this IoT device can run, any like a Python, Node, script. Basically, it's a small, Linux machine with 16 megabits RAM and 16 megabits disk space and 64 megabits of RAM. So yeah, I mean that's enough to control your home devices. Like if you are doing any simple home automation projects, this is good. This should be sufficient. And one more thing, it has built-in Wi-Fi, so you can connect it. You can SSH into this. On your network with your if you know the IP. So when you connect it, when you for the first time, you need to assign the IP and all those things. You can get it from online. But once you connect it, once you set up for the first time, so you don't need to connect it to the computer every time. You can just SSH, with the IP address. So, and this one also has 13 outputs, and it can output 3.3 voltage and 5 volts also. So yeah, so enough of talking. So let's demonstrate little bit program like LED program with this. Okay, so let me connect it to the, I already set it up to my computer, so I already know its IP. So I'm just powering it with a micro USB cable. So it just takes 1 hour, not more than 2 minutes to boot it up. So while it boot it up, let me bring up my SSH putty. So but I don't use putty, I use Mobaxter. So let me bring it up. So it's booting up. So this is simple LED light. So let me connect it to the ground. So I don't know whether you can see it. So it has a ground and pin 1. Okay, so the left sides are ground and 0, 1, 2, 3 and so on pins. So let me connect positive to the 0 terminal and negative to the ground. So the goal is with the program you're going to write, we should be able to blink it with maybe with a 1 or 2 seconds delay, okay, based on our program. So I think it's up. So let me okay, so yeah, it is up. So let me SSH into it. So you can see it's all Linux. So on the left side you can see I am in the root folder and I already uploaded the program. So but let me open the same program in my local machine, so which is SDK blink py. So this program, this blink LED program, is written in Python. So as I mentioned earlier, Onion Omega can, you can install Python, Node.js, PHP, whatnot, and then you can run the programs in your favorite language. So this is the simple, LED program. So what I did, I imported some packages. So Onion GPIO to access the GPIO. GPIO means, general purpose input and outputs. So I should be able, able to access those input and output pins, with this package. So for this demonstration, I'm going to use only one pin, pin number 0. So I just instantiated that pin, and then I'm setting the direction to output, because we are outputting the signal, right? We are outputting the voltage to the LED. So that's why I set it 0. If it is input, for example, if you are taking an input from any temperature sensor or any other device, you have to set the direction to 1, which is input, but in this case it is output, which is 0. So I created a variable called LED value 1, and then it goes into loop. So if it is 1, it sets the output to 0, which is low output. If it is 0, it sets the output to 1, which is high. So let me upload this to the IoT device. So what you can do is, you can simply select it and then upload it. So yeah, it is uploaded again. So let me run this with the Python. So when I run this, I don't know whether, yeah. So let me move these things aside. I don't need this for now. So when I run this program, so it should, it should blink with the duration 3 seconds. So Python. So another program running. So we can see, it stays on for 3 seconds, and then goes down for 3 seconds, and then on again for 3 seconds, and off again for 3 seconds. So it's pretty straightforward. Okay. So yeah, you can write the same program in, as I said, you can write in the PHP or Node.js, and then simply run it on this machine, and then it runs on forever. So it runs on its own. So the idea now is, to use the similar mechanism to control the DC motor in the air freshener. So what I want to do is, I want to, send the trigger signal, on the time I want. For example, I want it to fire, I want it to spray, for every 30 minutes between 6 a.m. to 10 a.m., and then after that, maybe once in for 2 hours, and then at the night time I want it to fire, maybe once in 2 hours. Or you can also say that, okay, I want it to spray at 3 a.m. and 5 a.m. or 10 p.m., something like that. Okay, just to give you an idea. So as I said, we can use a similar program. So let me bring it up, the program I've written for air freshener. So it's a similar, I just copied these lines from the Blink program. So it's much more simpler now. It doesn't have loop. So I'm specifying, because DC motor needs to run at least 2 seconds. That way, it needs to push the lever. The cog wheels needs to run for at least 1 or 2 seconds. That way, it can push the lever to the completely downwards. Otherwise, it cannot press it completely, and it won't spray it properly. So that's the reason I chose it. I want to stay the output to stay at least for 3 seconds, right? So I'm using the same pin. I'm going to use the same pin, 0, and then setting the value, which 1. That means I'm setting the voltage to high for 3 seconds, and then keep high for at least for 3 seconds, and then bring it down to 0 and bring the voltage to low. Okay. So, but the problem is, this is not the simple LED. this is this has moving parts, right? It has it has some induction behavior, so you cannot simply connect these wires directly to the Arduino. The problem is, with this induction behavior, it tends to draw high current when it runs, when it just starts, right? Lenz law, all this comes into play. So when it tries to draw more current, it may damage our IoT device. There's one problem, and the second problem is when it stops, when the motor, because we are setting the voltage to zero, right? So when we stop the motor suddenly, there may be negative voltage spike because of this motor's induction behavior, and that negative voltage spike also can damage your um, IoT device. So to protect and to circumvent these problems, so we need to use one transistor, right, and one diode. Why we use transistor? Because we know that from the basic electronics, a transistor acts as a switch, right? So let me bring it up, bring up the circuit diagram. So I'm going to use. So I think it's already on. So this is the circuit diagram. So this is the motor. So we have two terminals coming out of it. So this says NPN transistor. It's a general purpose NPN transistor, PN triple 42s, and this is I1N4001 PN junction diode. So what we are doing is this is the base, and this is the emitter, and this is the collector. So we are going to connect emitter part to the ground, and then emitter part to the ground, and then base part to the signal, which is 0th pin, and then we are going to connect the collector side of it directly to the motor, and then positive side of the PN junction, side of diode to the positive side of the battery, which is because as I said it can give you 3 volts output, so you don't need to use external battery. So yeah, that's another good thing. So once you finish the project, you don't need to use the AA batteries to power it up. You can simply just use your IoT device connecting to the micro USB. Okay, so yeah, so I already made the circuit, so I don't know whether you can see. So I just used NPN transistor, and then PN diode, and then a resistor which is a 270 ohms, but I don't have 270 ohms resistor, so I use a 330 ohms, but that's fine. So let me connect it to the terminals. So and then we will upload the program. So we don't need to upload the program, it's already uploaded, so we will run the program directly. So when I hit, when I run the program, it should be able to spray. So keep watching. So all right, so I connected the wires as shown in the picture. So 3.3 volts goes between the diode and to the motor, and then signal to the emitter of the NPN transistor, and then base to the ground. Sorry, emitter to the ground and base to the signal. So let me bring up the program. Okay, so this is the program, air freshener PY I'm going to run. So as I shown earlier, it is just simple program, just setting the 0th pin to high, and then you know keeping it high for 3 seconds and then bringing it to low. So, since it's a Python program, oops, I think it disconnected. Okay, let me log in again. So it's Python Freshener py, so that's the program. So when I, as soon as I hit enter, it should spray. So I can see it just sprayed, and then after 3 seconds it exits out out of the program. So let me do it again. So yeah, so as you can see, I'm able to control the air freshener with my IoT device. But my objective is not at completed, right? Because I want it to run at the specified times I choose. So there are two ways to do it. One is you can write your logic. Let's say since it's it's based on the it's running on the Linux, so you can get the system time, right? So right now it is 2:41 p.m. Sunday. So you can write your logic in the program itself. You can find whether it is like 6 a.m. in the morning. If it is 6 a.m. in the morning, then you can fire at 30 minutes of the interval, something like that. But I don't want to write too much logic for it. So what I can do is, because since it's running on the Linux machine, so I can use cron tab program. Crontab is a job scheduler that comes with the Linux distribution, right? So you can specify the timings and everything, and it runs the program you specify on that particular time. So let me open Crontab. So yeah, so this is the for testing I just write one line. So what it does is, this notation means it runs the program, okay, the script at every minute. So I just write it for the testing purpose, but I don't want it to fire for every minute. So this line, if you can see this, right, the one highlighted, right? So it says it triggers for every 30 minutes between 6 a.m. to 10 a.m. So yep. So one more thing I need to insert. I specify the timing, but I didn't specify what to do at that particular time. Oops. So it's clicking. Oopsie. This VA program is a little bit tricky. Okay, I came out. So let me start over. So it's Python /root/ air freshener. So it's fired again. So let me copy this, because this is the one we want to run at the specified time. So after this, so I've specified and then specify the time. Yeah, but anyhow, I commented it out. I will enable it later. So that's all. So if you enable this, it should run for the specified times, so 6 a.m. to 10 a.m. for every 30 minutes, and then it triggers at 12 a.m., 3 a.m., 6 a.m. That way we can save for example, if you set it at 36 minutes with the out of the box settings, it runs at least 40 times a day. But with these settings, you can spray only for 15 or 16 times. That saves the air spray in the long run. Spray with the specified time we have set in the cron tab, But what if I want to spray ad hocly, right? So what if I wanted to run, like maybe when I woke up like 5 a.m. in the morning. So to run it ad hocly, I wanted to control it, with a simple UI. So what that UI looks like is, um, it needs to show a button, spray button. If I click on spray, you know on your phone, or on your computer, it should spray. So that's the goal. So for that, we can make use of Node.js. So let me show you the Node.js program. This is a simple Node.js program, which you are seeing on the screen. So what it does is, it is using HTTP library that comes with the Node.js. So there are just one simple request. So air freshener. So this is the so when we receive the request with the URL context with the spray, that's going to execute our Python program once. So otherwise, it would just say that it would just show the button with the spray on it. So let me run this so that you can see the action. So let me bring up the SSH and then node onion server.js. So now the onion server.js program, that's going to run. So with our logic here, you can see, I started it at the for 3000. So then once it starts, so and that is 120 hours IP of the, and 3000 is the Node.js. So you can see, it has, I just kept one simple button, spray. Okay, so when we click on spray, according to our program, it is going to execute our Python program, air freshener program, which in turn sprays the air freshener. Okay, so let me click on spray. So when I click on spray, it should spray. So you can see that, right? So after 3 seconds, you can see small whirling sound. That means it's going down. So let me go back and then click spray. So this way, you can run this you can fire or you can spray this air freshener ad hocly. So I know this is not beautifully looking arrangement here, but if you have 3D printer, you can package it in a native fashion and then um, keep it in your living area.